Maps of flood risk areas are needed to improve both flood prevention and emergency services in case of crisis. However, although many of these maps are available at national or regional level, their aggregation on a larger scale is made very difficult. The methods and data used to generate these maps differ, which creates many inconsistencies and makes their integration into a single large-scale product impossible. It is this challenge that LIST aimed to tackle in trying to identify and explore new methods to map flood risks and thus produce large-scale maps.
For more than 20 years we have been measuring hydrological and climatological variables together with public authorities in Luxembourg. The main objective of these measurements is to better understand how floods are generated. The problem with those measurements is that they are mostly point observations in space, and new technologies like satellite-borne remote sensing have helped us to bridge that spatial gap and to have now information that is available over large areas covering several square kilometers and even up to several hundreds or thousands of square kilometers.
To develop our methods, we are using all the satellite images that are available in the archives of the European Space Agency. So all these images are interpreted in order to extract the flood extent. And in parallel, we are using a prototype of a global flood inundation model to also estimate the return periods of the flood events. So we can attribute probabilities of occurrence to the flood extent maps that we obtained from remote sensing. And by combining these two types of information, so flood inundation modeling and satellite-based observations, we are now able to map flood extent and flood hazard at global scale with a very high spatial resolution. The methods that we have developed in Luxembourg can also be used in an operational context to map the flood extent of the major events that occur throughout the world. We have been asked recently to follow the propagation of a flood wave that took place in southern Africa in the Zambezi region. At that occasion we used for the first time the data from the new Sentinel-1 satellite mission of the European Space Agency. With this data it will be now possible to map the entire European continent every 3 days.
The research projects that we have carried out over the past 20 years have triggered a certain number of important impacts. Among these we can cite the publications in international scientific journals. This has in turn led to interest from a certain number of highly renowned research institutions from all over Europe and beyond. Among these we can cite a research project that is co-funded by the German Research Fund and the Luxembourgish Research Fund. Over 6 million euros have been invested by the German Research Fund into this project that has as its main objective a better understanding of the flood generating processes. We can say that we have now come up with a product that stems from a quite unique setup where we combine observations in the field, remote sensing techniques and hydrological and hydraulic models. And this product has triggered interest from both national and international stakeholders.